Welcome back, students. Let us now discuss sections 1.2 and 1.3. Section 1.3 is more important than 1.2, but we have to start with relatively unimportant one, 1.2. Measurability and variability. As the name suggests, it has something to do with variables, so we have to talk about variables. What is a variable? It's not the same as the variable in algebra. A variable in statistics is a certain characteristic of interest of a certain element of a population or a sample. So it can take various values. It can take numerical values, yes, but also it can take nominal or ordinal values. For example, if your survey is asking what is your favorite dish or something like that, then the variables can take data values such as the kind of names of food. And certainly we cannot put any numbers attached to it, so we have just nominal variable. That's an example of qualitative variable. In some cases, we may have ordinal variables, which are still names, but we can put some orders onto it. Not precisely numerical value, but some order. For example, if the question is asking about your favorite dish and second favorite and third favorite food, things like those, then you'll have ordinal variables, but still you'll have just names of food. You cannot put any numbers to those, even though to a certain degree certain order is possible. In some cases, ordinal variables, can take a little bit more numerical values. Consider letter grade A, B, C, D, and F. Those are certainly ordinal variables. By themselves, they are qualitative. They don't have any number. But we have preference. A is better than B, B is better than C, C is better than D, and so on. But if we put grade points to those, A is 4.0, B is 3.0, things like those, and calculate GPA, then those are now numerical variables, quantitative variables. And those kind of things are examples of discrete quantitative variables. In some other cases, these quantitative variables will be taking entire real numbers or all the real numbers between a certain interval. We considered an example of size of fish in previous examples. In that case, we have measurement of length of those fishes measured in inches. Those are real numbers, so those are examples of continuous quantitative variables. We have these kind of classification. Nominal, ordinal, those are qualitative. Discrete and continuous, those are quantitative. And as you move from top to bottom, we have more numerical aspects, so to speak. And nominal and ordinal variables are not measurable. Nominal variable, absolutely not. Ordinal variables, to a certain degree, depending upon circumstance, because there's some gray area between one and the other. Quantitative variables are measurable. We can put numbers in there. But variability is not directly related to variables. Measurability is, but variability is not. Variability is for the variables taking different values each time you do different experiments, so we have various results. And if you have a list of those numbers out there, then variability usually stands for how those numbers are spread out. Those kind of things are called variability, and we use the terms like variance or standard deviations. Those kind of things measure variability. Not that it's really important. Okay, let's move on to something a little bit more important. Data collection, section 1.3. How do you do data collection? We do by sampling. I mean, if you take numbers directly from population, well, typically it is going to be impossible unless your population is exceptionally small. In that case, of course, you can do all kind of things with just population alone. But that's rare. Most of the time, you have to deal with huge population, and take those numbers from those population will be very, very difficult and time-consuming and expensive. And also, by the time you analyze, the characteristic of your population may have changed. Well, everything is going to move. So what do? We take the sample. A small subset of a sample, small subset, did I say? It should be large, but not super large, like 1,000 or something like that. and do some statistical analysis about the sample, and you can apply it back to the population. That's basically what we do in inferential statistics. The key thing here is, how do you get data out of there? And that mechanism is called sampling. And sampling, if it is not done well, then it can produce a sample that is not good, called a biased sample. And that is different from sampling error. Error is inevitable. It can take place one way or the other, and it is related to randomness. But bias is rather systematic. So we have some systematic difference, and that's called biased sample. And let me explain what this bias means. And one of the best way to deal with that is to look at what actually happened. I put a couple of websites here. And one is about presidential election that took place in 1936, forever known as Literary Digest headline, Landon in Landslide. Of course, everybody knows what happens actually. It was FDR, Franklin Delano Roosevelt, who won presidential election and stayed there for 4 terms. Well, I took the liberty of opening up those already. And here in Wikipedia, we have some brief history about United States presidential election, 1936, and even more, what happens to a magazine called Literary Digest. And what they did was they took a survey based upon a list of names, and they took those names from telephone books, the wedding list of some famous people, and customer list from country clubs and things like those. Telephone books nowadays may not be too much biased, but at 1936 it was heavily biased toward rich people. And even though they spent, well, let's see, 2.4 million responded individuals, they ended up with garbage results. They predict Alfred Landon in landslide, but what happened, well, everybody knows. By the way, in the same year, young mathematician George Gallup run his own survey with much smaller sample size of 50,000 compared with 2.4 million, come on. And using this result, Gallup very accurately predicted that Roosevelt will win 56% versus actual vote 61%. Okay, did I say really accurate? Okay, I take it back. It wasn't really accurate in that sense, but still, as far as the outcome is concerned, yes. By the way, you always have to consider some bias in those kind of election polling, because usually relatively poor people have more tendency to not responding to the survey, and that always causes some headache. Anyway, that's how Gallup's name became notorious, and then Gallup Institute became one of the largest and one of the most influential poll company these days. And Literary Digest became a kind of joke, and became a kind of case study example these days. And that kind of thing is called bias, not the error, not the polling error, but bias. It was systematic difference toward richer people, because the list, what we call sample frame, was taken from relatively rich people, like phone book or guest list from country club and things like those. And those kind of jargons are explained briefly here. Sampling method, a process to select sample, okay. Bias, I explained it, is systematic difference. And sampling frame, a list of elements from which we take random selection. Getting a sampling frame is often difficult. If you start from good sampling frame and then do the random sampling, great. But if you do not start with the right sampling frame, then even though every mathematical steps you take afterward is good, you end up with a garbage result. And sample design is, of course, overall design. And how to get a good sampling frame is usually a big deal, but we do not deal with those kind of things in this course. Here is a rough idea how those sample designs work. Probability samples and judgment samples, you just make judgment out of convenience. Come on, that never works. You have to use probability samples, but single stage or multi-stage. Single stage is definitely better and mathematically superior, but it's hard to do that because you have to have overall list right away in order to get those. So how do you get a sampling frame? That's a big issue for single stage. Multi-stage is more practical. For example, if you want to do some prediction for entire U.S. presidential election, then you go to each state, and in each state you go to each county, and in each county you go to subblock and subblocks, and each time you do, you put appropriate probability there. Probability, I mean by proportion of population of Dallas. I mean number of votes being casted in Dallas County over the number of votes being casted from the state of Texas, for example. And in Dallas County, again, you have to do appropriate subdivision. You have to put appropriate probability into those and get those into smaller and small clusters. And then in Dallas County, you select a certain clusters here and there. In those clusters, you get a list and then select people out of random. So we have multi-stage random process there, and that's usually the kind of thing we do. Sometimes you stratify the random sample rather than taking random everything, but do those instead. Do those in every third or something like that. But usually those are not really good. But sometimes we have to compromise. Cluster sampling is of course good, but I mean the kind of multi-stage with all those statistical process or stochastic process involved, superior, but a lot harder math is involved there. Multi-stage method, we're not going to deal with those kind of things in this class, I'm afraid. Those are more practical, yes, but mathematics behind those are too hard for 1000 level math courses. What we are going to do here is exclusively simple random sample, top right hand side corner. We talk about all these kind of sampling technique, but we talk about something just too simple and maybe too simple and unrealistic. Some naysayers may point those out and scoff at us, but then again, everybody has to start somewhere. This is 1000 level math course, please remember. And just like doing an experiment from vacuum tube first, and then later on you put in air resistance, friction, and so on later and later on, and eventually you put all kind of other effects, like quantum effects or relativity kind of things as well later on. But everything begins with something really simple. Likewise, here in statistics, we start from simple random sample only. We have some questions about other things, but only in chapter 1. Afterward, we are not going to come back to any of those. Okay, there are some other ways to get statistical analysis. Those are experiments. Typically, we use controlled experiments. And we divide a group into two, control group and observational group, or experiments group. And then at experiments group, we have real drug, and control group, we get placebos, and then we compare those two. The mathematics behind it will turn out to be a little bit difficult, and we're going to deal with those kind of things in latter half of the semester because we have to compare two independent samples. Okay, that's it for chapter 1.